Accurate and comprehensive valley bottom delineation, as depicted in yellow in this slide, is a necessary first step for several of the GIS network analyses that we're currently doing, including the riparian vegetation condition assessment and river confinement estimations. Valley bottoms are the low-lying areas that contain or could support the reestablishment of riparian vegetation. Valley bottoms are areas physically suitable for riparian restoration. These are areas that are physically connected or capable of being reconnected to the river channel. The width and configuration of the valley bottom determines the level of river confinement. Therefore, it's critically important that we derive accurate and comprehensive valley bottom delineations. In the context of the Columbia River Basin being so large, the task is quite daunting to delineate all these valley bottoms. So in talking with Joe Wheaton and discussing options for how to monitor our progress, we decided that the Trello site would be a perfect way to go forward with this. So we created a John Day Valley Bottom delineation board, and within that board we have this workflow, and the workflow goes through the generation of the valley bottom using the fluvial corridor tool and goes step by step through using a checklist, so the technician, as they go through, can check off these steps. So the steps are: run the headwater settings, validate the results of the headwater settings, and adjust as needed. So using hillshades, topo maps, and Google Earth, come up with the settings that are appropriate. Once you're satisfied, run the main stem settings, validate these settings, and then adjust as needed. So once you're satisfied with both your headwater and your main stem valley bottoms, run the script that Jordan's created to merge the headwaters and the main stems. And the transition between these two will need to be edited because they're going to be noticeable, and so we want to make these seamless. So there's manual editing that's required in this step here. So once we're satisfied with the generation of these valley bottoms and how they look merged together, the thought was at the HUC 6 level, so that at the basin level, we would just do a coarse 1 to 24,000 scale editing to remove all the gross errors. So using Google Earth and ArcGIS Explorer, base maps, hillshades to get context. And once that's done, the idea would be fine scale manual editing within these focal HUC 8s. So in this example, in the John Day, it's the middle fork HUC 8. And so this scale, for this area, using a scale of 1 to 10,000, like we have in the Colorado Plateau, to remove the valley bottom errors. Then the idea is once our manual editing has been completed, we provide a KMZ file of that focal area, the focal watershed, in this case the Middle Fork John Day, to Gary O'Brien, where Gary would validate in Google Earth or ArcGIS Explorer and would identify using point markers places where he felt the valley bottom could be adjusted, where there might be errors or changes in line work would be needed. So Gary would provide this point file back to the GIS technician, and then in a final QA/QC step, the technician would fix those changes that Gary suggested, and then he would provide Gary with a finalized version. Gary would evaluate it, and he'd either sign off on the changes or provide additional changes that are needed and send it back to the GIS technician. And in that case, these steps would be repeated. And then finally, this finalized valley bottom and associated metadata would be provided, would be uploaded to the iSimp Ignite folder, the appropriate folder on Ignite. So that's what we're kind of thinking as far as a workflow, and then we can track what's going on, what's going on right now in this doing card, and then we can also add what's done, and we can add in timelines for deadlines by which these different tasks should be completed. And so the idea of this would be done for each of the basins or sub-basins within the Columbia River Basin. All right, thanks for your attention.